Hi, how's it going? Welcome to Code with Z. In today's video, we have to find the product of this array. Why? Well, because that's what LeetCode 238, product of an array except self, is asking us to do. Now, as you can see, it says, given an integer array called nums, for example, this one, return an array, for example, called answers, and I'm going to show you how this works in a bit, but let's first read the question. So return an array called answers such that answer at the index of I is equal to the product of all of the elements of nums except nums at the index of I. I know this is like a little bit foggy, don't worry because we have a visualization. And as you can see, it says the product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer, and we have to write an algorithm that runs in time complexity of n. And we can't use any division. Alright, let's see what the product of an array except self even means. Well, as you can see, the product of this array is basically this array here. Why? Well, for example, if we take a look at 24, 24 came from 2 multiplied by 3 multiplied by 4. So 24 is the product of this array except self, except 1, which is at this position, as you can see. If we move on to 12, for example, 12 came from 1 multiplied by 3 multiplied by 4. Why did we ignore 2? Because we have this position. And as you can see, these two have the same position, so we're going to ignore the position that the number has itself. So for example, because the position has the index of 1, we're going to ignore the number that has the index of 1 over here. For example, for 8, 8 came from 1 multiplied by 2 multiplied by 4, and 6 came from 1 multiplied by 2 multiplied by 3. Alright, now that we know how this is calculated, let's see how we can solve this. Our approach is going to be super simple. We're going to do two simple things. The first one is that we're going to go from left to right, saving the product of everything before each number in a list. Now you might be like, what does this even mean, Z? Well, don't worry because I'm going to visualize it for you. So I think we can all agree that we need to return something, right? And that something is basically the product array. So let's have a variable called result, and this is going to be initialized to an empty array. This is going to be the thing that we're going to return at the end. Now we need something called a prefix, and this prefix is just going to be initialized to 1, and you might be like, why? You're going to see how this works with your own eyes because there's going to be a visualization. You don't have to rely only on my explanation because I'm going to visualize everything for you. So we're going to have a process. We're going to loop through this array, and then we're going to do two simple things in this loop. Well, let's start. When we loop, we're going to start with 1 because this is the first element in our array, and then each time on each round, we're going to put the number that prefix is equal to into result like so. And then we're going to multiply prefix by the current number that we have. So 1 multiplied by 1. This number 1 that's in red is basically the number that we have here. So now prefix is also 1. Now we move to the next round. This time we're going to repeat the same thing. Put this over here like so. And then we bring this down here to multiply it with prefix. Well, 1 multiplied by 2, that's going to give us 2. And then we move on to the next round. Again, same thing. Put this over here like so. Bring this down here to multiply with prefix. That's going to give us 6. And then we move on to the next round. In this round, again, we're going to put this over here. Then we bring this down and multiply 6 with 4. So that's going to give us 24. Now that we're done, because we basically went through all of the numbers that we had in our array, you might be like, what does this array represent? This array represents the product of all of the numbers that come before each number. So for example, if we take 4, for example, the product of all of the numbers that come before it is 1 multiplied by 2 multiplied by 3. Well, as you can see, we have 6 over here. So in the position of 4, we have 6, and this is the product of all of the numbers that came before it. So the approach is that we break down the problem into two parts. We first calculate the product of all of the numbers that come before our number, and then we calculate the product of all of the numbers that come after our number. So to do that, this time we're going to have a variable called suffix, and it's going to be really similar. It's going to be initialized to 1, and then we say that we go from right to left, multiplying by everything after each number to complete the list of products except for each spot. Now, what does this mean? It's basically the same thing that I told you. We calculated the product of every number before the current number, and now we're going to calculate the product of every number after the current number. Let me show you. We're going to be like, okay, we start from the end, so we go from right to left. So our current number is going to be 4. We're going to be like, okay, multiply the position that we have currently in our result array by suffix. As you can see, this is the position that we have in our array. So this is the position that we have to change in our result array. So we multiply 6 by 1. As you can see, this 1 came from here. That's going to give us 6. And then we multiply our current number with suffix, like so. Now suffix is 4. And then we keep going with our loop. In this round, our current number is 3. So this is the position that we need to look at. And then we multiply this position with suffix, the number that we have in this position with suffix. That's going to give us 2 multiplied by 4, and that's going to be 8. And then we multiply this with suffix. That's going to be 12. And then we keep on going with our loop. In this round, we have 2. So this is the position that we need to look at. And we need to multiply this number with suffix. So 1 multiplied by 12, that's going to give us 12. And then we bring this down and multiply it with suffix. So 12 multiplied by 2, that's going to give us 24. And then we keep on going with our loop. The current position is going to be this one. So you have to multiply 24 with 1. And that's going to give us 24. And then we bring this down here and multiply by suffix. And we're done with our loop. And if you actually take a look, we are actually done with everything because this is the result that we were looking for. 24 is the product of 2 multiplied by 3 and 4. And then, for example, 12 is the product of 1 multiplied by 3 by 4, and so on and so forth. So basically, what we did was to break down the problem into 2 simple parts. We first calculated the product of all of the numbers that came before our current number, and then we calculated the product of all of the numbers that came after our current number. Now let's code this in the simplest way possible. Alrighty, let's code this together. So the very first thing that we need is gonna be our result array. So const result is equal to an empty array, just like we saw in the slides. And then we have our prefix variable, and this is initialized to 1. And then we have our first loop. We're gonna say for let I being equal to 0, and then we want to keep on looping as long as I is smaller than nums.length, which is basically the length of our array, and then I++. Here we're gonna have literally the same thing that we had in the slides. We're gonna say result at the index of I is equal to prefix, so we're putting the value of prefix inside result at the position of I, at the position of our current number, and then we say prefix is equal to prefix multiplied by nums at the index of I. Basically the same thing that we had in the slides. And then we have our suffix. We're going to say let suffix be equal to 1, and then we have our reverse loop. We're going to say for let I being equal to nums.length minus 1 because we are 0 indexed, and then we want to keep on looping as long as I is greater or equal to 0, and then I minus minus on each round. Here we're going to say result at the index of I is equal to the result at the index of I multiplied by suffix, like so. And then we say suffix is equal to suffix multiplied by the current number. And at the end, we're going to return our result. So we basically broke down the problem into 2 parts, just like we saw in the slides. Now let's run this and see if we can actually get accepted. And we got accepted. Now let's submit this and see if we can actually pass all of the test cases. Let's see, and yep, we got accepted. That's awesome. Thanks for watching. Don't forget to like and subscribe and keep on coding.